Welcome, welcome everybody. I'm actually slightly overwhelmed by the attendance tonight. I know this is your Friday night, but boy, we're going to make it good. We have a great guest speaker tonight, who's Britain's foremost deep ocean explorer. I mean, beat that, fantastic. We're going to learn an awful lot together. Let me start at the beginning. Why are you here? Why am I here? Well, I was at Atlantic College myself, and boy, it just changed our lives. And I can see it all in all of you, the passion and the enthusiasm you all have, and the strange ideas you all have, which is what we want. Instead of words, it's action. That's what we're going to do tonight. I'll just give you one small example of something I did start a few years ago. You know, when 3 in the morning, you have those crazy dreams. I was in Africa in the bush. It was very hot, being bitten mosquitoes, and you're a bit crazy. It's 3 in the morning. You're crazy, but you're very sane. And I had a dream. I was with a friend of mine who was one of the world's greatest zoologists in elephants. And I said to him in the morning, I said, we're going to start Save the Elephants. He looked at me and he said, let's do it. That night we camped on the shores of Lake Tanganyika in the sand, and by the moonlight, by the campfire, we talked about this. An American guy who was part of the show, he said, hey boys, you got any money? No sir, no we haven't. He went behind the tent and he came back with a check for $5,000. And that was a lot of money then. He said, boys, get going and do it. Now, I say this to you because all of you can have the same dream, do the same things. And that charity is now world famous and has influence from America right through to China. Joining people together is the great thing. The scientist, the ordinary person. Atlantic College is the perfect place to start this. You have absolutely everything you could possibly want to get into the marine world right here at your fingertips. You have boats, boat building skills, like nobody else. You created the rib that has saved millions of lives. I'd like to say also, you have great teachers here. A legacy in this castle for great teaching. And I think we should praise them and say thank you for being with us tonight. It's fantastic. You don't have to think you have to be a top scientist to do these things. I guarantee that every single one of you in this room has the tools to do it. Even if you've never been in the ocean, we need the scientists. We need all of you. And very often, the humblest ideas are the best. My passion is that this college will be the world leaders in it. And anyone who eventually does this course will be ready, have a certificate of saying, yeah, you're pretty ready for the oceans. But tonight, enough from me. I think it's time that you all close your eyes and put your goggles on, and we might meet the real ocean diver who will really bring us into the oceans. So thank you so much.
Well, thank you for your introduction there, Felix, and thank you to everyone involved in the organisation tonight for the invitation to come and meet you and all the wonderful arrangements and superb hospitality that I've enjoyed. And also thank you all for giving up your time to come. It's so encouraging to see such enthusiasm for the oceans, for the future of the oceans. Now, you're all familiar with the idea that Ours is a blue planet when we look at it from space because so much is covered by ocean, but that's actually, that blue appearance, just the reflection from really a thin veneer surface layer. Because if we do some very clever tricks with satellites and we can take the water away and reveal the landscape of the deep ocean floor, what we find is actually the average depth of the ocean is perhaps deeper than we might imagine. It's 3.4 kilometres. Or to look at it another way, more than half our world is covered by water that is more than 3.2 kilometres deep. So to an ocean explorer like me, ours is not so much a blue planet as it is a dark, deep ocean world, because sunlight only filters down through the top kilometre or so, and that's what gives us the blue as it reflects back. So what I want to do here is to take you on a bit of a tour of this hidden landscape, this hidden face of our world. And we're going to go beyond, I think, the depths of some of the marine life that we love and we're most familiar with. So, for example, if we think about whales, here's a lovely humpback whale doing a bit of spy hopping. This was a photo taken in the Antarctic. The deepest diving whale that we know of is a kind of whale called a Cuvier's beaked whale, and it gets down to just about 3 kilometres deep. And yet the deepest point in the ocean, that's not even the average depth of the ocean, the deepest point in the ocean is just short of 11 kilometres deep. So whales go not even a third of the way to the deepest point. Although I have a former student who's got evidence that maybe whales get to about 4 kilometres deep. But I don't think they go all the way to the bottom on a breath of air. And what about sharks, that other iconic animal from the oceans that we're often fascinated by? Well, I'm afraid I have to tell you that sharks and animals like sharks don't go any deeper than 4 kilometres deep because of what happens with the chemistry of the cells of their bodies. So, not only is our ocean dark and deep, but actually most of its inhabitants are things we're less familiar with. They're not these amazing iconic animals. And that means there's plenty out there for us to explore. And that's essentially what my job is. So what I'm going to do is take you on a journey across the ocean, but not travelling on the surface like this. We've been travelling across the surface of the oceans for maybe 40,000 years, our ancestors. If we look at things like the first human colonists to reach Australia, who must have come across some stretches of ocean to get there at that time, now it's a great time to be an ocean explorer, because for the first time in history, we have the technology to reach the deepest recesses of that ocean. So we have these amazing human-occupied vehicles. You may recognise this one from Blue Planet 2. This was the one that actually did all the filming from Blue Planet 2, and it takes 3 people inside this sort of acrylic bubble there. And then for subs that take us even deeper, this goes down to 1,000 metres deep. For subs that take us much deeper, indeed all the way to the bottom of the deepest trenches, slightly different design, and it's a hollow metal ball at the heart of this with 3 people crammed inside. And this is one I've used to dive into the Cayman Trough in the Caribbean Sea. And we don't just have mini submarines like this that can take a few people into the deep ocean. These days we also have these incredible remotely operated vehicles. So this is not carrying people. This is remotely controlled via a long cable from a ship at the surface. We stay in comfort aboard the ship, and it allows us to, when we're using this, our minds are on the ocean floor, even if our bodies aren't. And its cameras are our eyes, and its manipulator arms are our hands for working and exploring in the deep ocean. Give you some idea of how big this is. Here it is with some of my research team for scale. It's about the size of a sort of family car. And we stay in this control centre aboard the ship, and now we can even do better than that. We can beam these pictures live back from ships onto the internet, and you can all be ocean explorers right now. In fact, I can share some of the links. There's an expedition happening, 2 expeditions happening right now exploring the deep ocean. Any of you can just visit this webpage and watch live as these vehicles dive. We see creatures maybe we've never seen before. You can ask questions from the team on the ship. You can all be involved right now today. So it's an exciting time to be an ocean explorer. And what I'd like to do this evening, given that this is Atlantic College, I'd like to take you on a trip across the Atlantic, but perhaps like no other. We're going to cross the Atlantic via the ocean floor. What would it be like if we could take an incredible 6,000 kilometre hike from Lisbon in Portugal, slightly winding route to take in some interesting things I want to share with you, and we're going to end up at San Juan in Puerto Rico, okay? So we're going to have a journey across the Atlantic, but down below in the dark depths. So let's imagine that journey. What would we see? What's the landscape like down there that we're still exploring? What are some of the life forms that we discover down in the ocean depths? So let's head off out of Portugal, launch our submersible for that journey. I had to put this slide in because, hey, we need ribs to launch submersibles. What better place to come and talk about that? Okay, but detaching our sub from the ship, starting a journey. If only a sub could actually go that far on a single trip, it would be a fantastic voyage. Let's look at how varied the landscape is of the deep ocean, because it's not something we think about. So if we start up here in Lisbon, imagine we launch here, the first, first sort of 40 kilometres or so of our journey, we're on what's called the continental shelf. So this is the shallow bit of the oceans, the seas, that fringes the land. And here it's about 150 metres deep, which is deep for scuba diving, of course, but it is not deep in the scheme of the oceans. Okay, remember, average depth, 3.4 kilometres. And it's pretty flat, okay? It deepens very slightly, but probably no more than a sort of 1% incline as we're heading out initially, first 40 kilometres from Lisbon. If we were walking, we wouldn't even notice that kind of incline underfoot. And then we get to the edge of what we call the continental shelf. And here, over a few tens of kilometres, it drops off from 150 metres deep to 4,000 metres deep. On average, about a 10-degree downward slope, and in some places much steeper, in some places vertical cliffs. So what do we see if we were going to take our sub down one of those undersea canyons? We'd see things like this. These are deep sea corals. The corals we're familiar with, the barrier reef and so on, that's an animal, a coral, and it's a type of algae living in association together, and that's how they grow rapidly and build reefs and so on. But in the deep sea, we're beyond now the reach of sunlight. So there are no algae living with these corals, unlike the shallow ones. Instead, these grow incredibly slowly. Here's a close-up of them. Each little polyp exists by catching its prey, any small sort of animals or particles passing by. And this coral grows at about 1 millimetre a year. Very slow growing compared to the shallow water sunlit corals, which also means they're very vulnerable, they're very fragile. You know, if these are damaged by trawling or whatever, they take a long time, centuries, to regenerate. And the coral itself is home to an awful lot of other marine life. Fish, crabs, lots of other brittle stars, you name it. Hundreds of species associated with these deep water coral reefs that we get on the continental slope and in these undersea canyons. So, if we drop down then to 4,000 metres deep, we've come that little way from Lisbon so far, we then come to this thing on our journey, on this particular journey, called the Tagus Basin, and this is what we call an abyssal plain. So over the next 400 kilometres, okay, from the bottom of the continental slope out to the middle of the Tagus Basin there, the depth only increases by another 500 metres. Again, it's a very shallow sort of bowl, if you like. Again, we wouldn't really notice it getting deeper underfoot if we were walking on it. And this sort of very shallow-sided bowl is filled with fine mud. It's what we call an abyssal plain. What is that mud? Where does it come from? It's organic detritus that's sunk from above. So in the surface of the ocean, we've got microscopic floating algae that bloom in springtime and so on, and when they die, or they're eaten by tiny little crustaceans, and they then poo and what have you, all of that material sinks down. We give it the very poetic name of marine snow, but actually it's mainly poo. And it settles at the bottom of the ocean. And it forms very, very thick layers. I mean, in some places over millions of years, depends where we are, it can be a kilometre thick, this soft mud, before we get to actual rock underneath that. And so it looks a little bit like this. Here's a close-up of one of the inhabitants of an abyssal plain, the Tagus Basin. This is a sea cucumber. And this makes its living, basically, ploughing its way across that plain of fine mud, and it swallows all the particles, and it extracts whatever nutrition it can from what's remained from sinking down, and it's pooing out the rest continually behind it. Now, if we were to turn south at the middle of the Tagus Basin and start to head south, if the water weren't there and we were looking ahead, we'd start to see two very impressive mountain peaks rising up ahead of us. So here's the Tagus Basin. If we were to turn south, we'd start to see these. So we're at 4,500 metres deep here. The top of these mountains is just 50 metres below the surface. So they rise more than 4,000 metres up, very nearly breaking the surface. And they're twin peaks with a little sort of ridge in between them. And this is what we call a seamount, an underwater mountain. There are 39,000 or so of these worldwide that are more than 1,000 metres high compared to the surrounding seabed, which is what defines a seamount. Most of them are undersea volcanoes. They grow as undersea volcanoes. Sometimes they break the surface and become islands, and we get, the Hawaiian island chain and so on. But most of them don't. They stay underwater. This one's a little bit different. This actually didn't grow as an undersea volcano. This grew where two plates of the Earth's crust were sliding past each other, and one sort of pushed the other one up and gave us this feature here. So let's imagine we're climbing up Gorangi Bank, this incredible seamount. This is a deep sea coral, and it's got this lovely snake-armed brittle star living on it, using it to actually sneakily climb up and catch a better meal from the passing currents. So there are, I think, more than 800 species have been recorded in a recent survey on Gorangi Bank. There's even kelp right at the top, very deep kelp at the top. But unfortunately, also that survey has found other things. So, abandoned fishing gear. Because seamounts are such a hot spot for life, it's not just the filter feeders, it's also fish tend to congregate around them. So, okay, there are human impacts, okay, even in the deep ocean, even in these remote places like the seamounts in the middle of the ocean. So let's weave through here. We're going to cross some more abyssal plain. This is it's called a Venus flytrap anemone. And it's actually on a stalk of a dead sponge here, and it's using that to get a little bit higher up off the seabed where there's a little bit more ocean current, where if you're trying to catch a meal as an anemone, that's a good place to be. There are scavengers, of course. This is what we call a grenadier fish. So, this one might be hoping for something like a dead whale. That's a feast for months to come. But there are predators, of course. But because life is quite scarce down there, or scarcer the deeper we go, then it makes sense, rather than chasing prey, it's actually a better bet to be what we call an ambush predator. So here's a tripod fish on the abyssal plain that does that. It rests on its pectoral fins here and its modified tail fin, so it's not expending any energy. It just sits there facing up current and waiting for something to detect something that it might eat. Okay, we go across that abyssal plain. We're going to turn southwest, and I'm heading for this another amazing seamount. This one's called the Great Meteor Table Mount. And this one was discovered in 1938 by a German ship called the Meteor, using sound pulses to map the ocean floor in much more detail, much more efficiently, reveal the existence of that seamount. And I like it in particular because at about 2.8 kilometres, all the way around the edge of that seamount, in a sort of ring, a band around it, is this incredible garden of glass sponges. So these are sponges whose skeletons are made of silicious spicules, glass spicules to make its skeleton. And you can see the glass stalks they live on, their filter feeders. Absolutely incredible to see that kind of thing in the deep ocean. Okay, let's carry on our journey. Let's leave Great Meteor Table Mount. We'll head west now. As we start to head west from the Great Meteor Table Mount, the seafloor starts to become a bit more rugged, and we cover a couple of 100 kilometres of something called abyssal hills. About 400 metres long, maybe 100 metres high, undulating hills with some bits of rock poking out of them. So, that's what the abyssal hills look like. We might see something like this lovely frogfish. Here, you can see it's got modified fins. It walks around on the seabed. And you can see it's rocky here, it's rockier in this sort of terrain, less fine mud. And here's a zooming in on the actual mid-ocean ridge that we're climbing up coming from the east here, okay? And at its heart, there is a rift valley. It's about 25 kilometres across, okay? And it's about a kilometre deep compared to the bits on the other side. And really sheer cliffs down into it. It really is a rift valley, just like the Rift Valley in East Africa. And it's actually kind of the same process. This is where the plates of the Earth's crust are getting pulled apart. And they're leaving this scar, and lava is welling up and erupting from the seabed here to fill that gap between the plates as they get pulled apart, as they ride around on convection cells in the Earth's mantle. So this is actually where the new Earth's crust is being created by undersea volcanoes along this volcanic rift. It's our planet's greatest feature. It explains how our planet works, and yet people only became aware of it 60 odd years ago. And in fact, it was this lady, Marie Tharp, who discovered the full extent of the mid-ocean ridge and that it had a rift valley and that this is where the plates were being pulled apart. She's one of my heroes of ocean exploration. She's one of the greatest deep sea explorers, even though the sexism of her time prevented her from going to sea. She wasn't allowed to go on research ships. She stayed ashore, collating the information from their echo sounders as they crossed the ocean, and producing this map that showed the full extent of that ridge going all the way around the world, and that it had a rift valley at the top of it. Wherever you looked, there was a rift valley. And scientists at the time did not believe her. They didn't believe this process was happening. Then Jacques Cousteau lowered a camera in 1959, actually, I think, hoping to disprove her idea, and then realised she was right and became a big supporter of her. And eventually scientists came around to the idea, collected other evidence that this is where the Earth's crust is rifting apart all the time. This is what shapes our world. And she was the first person to glimpse it. So what does it look like now in terms of our terrain? Very rugged. There's no sediment here, there's no fine mud, because this is brand new crust. There hasn't been time for layers of mud, of stuff sinking from above to build up here. So it's bare rock. These are what we call pillow lavas. This is a lava that's erupted and quenched and immediately kind of, being frozen as it's entered the cold ocean. We still get life from this lovely anemone here. And most exciting, if we cross the mid-ocean ridge, where I had in mind there, dotted along it, you get these incredible undersea hot springs that look a little bit like this. And this is actually what I spend most of my time exploring and researching. So these are just like the geysers of Yellowstone or Iceland. Okay, now there on land, they're erupting steam, and they're doing it every so often because the thing below fills up with water and then it boils and gives us steam. Here, this is a continual eruption of very hot stuff. It's not steam because we're 3,100 meters deep, and that pressure prevents it from boiling into steam. So it's 300, 400 degrees C fluid that is not turned into steam. And it's got this amazing sort of dark purpley black color because it's loaded with dissolved minerals from the Earth's crust. And then they're precipitating out and building these towers, these spires of minerals, building up this sort of thing on the seafloor. I'll take you to one. This one isn't actually in the middle of the Atlantic. I did start my career exploring them in the Atlantic, but the video from 25 years ago is rubbish compared to today. So here's a recent expedition from 2013 that I led in the Caribbean, looking at these things. And you can see they're teeming with life. So these amazing shrimp, that is the kind of thing you'd see at the middle of the Atlantic, slightly different species, but same kind of animal. Anemones. Okay, and you can see maybe it looks like the water's shimmering. That's because it's warm. It's like the heat haze on a hot day from a road. This is actually at 5,000 meters deep in the Cayman Trough of the Caribbean. Okay, it's a bit deeper than the Mid-Atlantic Ridge, in fact, there. Okay, so incredible marine life down there. And I spend my time basically discovering new species down there, figuring out who's related to who, why do we get some species here and a different species over there, and then what does that mean for understanding our effects on the deep ocean. So, finding new species all the time is a species of fish my team recently found and described. So we managed to collect one, we collected 3. We don't want to collect many, but we do have to look at their DNA and their anatomy and so on. This is basking in sort of 25-degree warm water. And there's a CT scan of it. So we can measure its skeleton and show that it's different to all the other species of fish. We can even see what it had for lunch. And it had shrimp, all those shrimp you saw in the video. Okay, so one of the things we find now we're worried about at these deep sea vents is a future that involves deep sea mining, because those amazing mineral spires contain a lot of metals, and we need metals in our modern lives. We love our smartphones and all the rest of it. We need metals for that. We want cars that run on electricity rather than petrol in the future. We need even more metals for those cars. Where are those metals going to come from? One place is possibly the deep ocean, but we have to choose our path very carefully there. So, for example, those deep sea vents I showed you, people are interested in the near future in mining them for copper that they contain, because it's richer than on land. And yet, the total area of those little hot springs around the world, because they're just dotted along the mid-ocean ridge, add up the whole area, it's about 50 kilometers squared. That is half the area of Disney World in Florida. And there are hundreds of species that are only known in that environment, in those hot springs, in that 50 kilometers squared globally. And you want to start mining that. That's very dangerous in terms of losing biodiversity. And then, seamounts that we visited. They also are a source of cobalt, which we need for electric car batteries, various other things. Yeah, okay, they cover much more of an area, but they've got those slow-growing corals on them. You know, damage there to the marine life will take centuries to repair. So if we start damaging them faster than they're regenerating, we're going to be in trouble and lose biodiversity. And then the abyssal plains, we can get rare earth elements we need for touch screens and things there. Yeah, okay, they are huge. We've seen that in vast areas. We could probably mine parts of those, and the species live over vast areas in their populations. Different kind of impact. So one of the things I spend my time doing these days is trying to talk to politicians about this and get them to realise that deep sea mining is not one thing. Okay, each environment, each habitat we've seen already on our tour is going to be affected in different ways, and we have to plan carefully in the choices we make for the future. So let's leave the Mid-Atlantic Ridge. If we stretch out to the west, more abyssal hills, more and more abyssal hills, and we'll turn southwest again and head towards another abyssal plain. Okay, so I'm bringing us nearly all the way to the end across the Atlantic here. Abyssal hills, yeah, lovely things. We'll see like this incredible anemone. Now this, when we came across this isn't just a new species. This isn't just a new genus, which if you've done any biology, that's like the next thing up from a species. It's not even a new family. This is a new order of sea anemones. That's the kind of thing we can discover in the deep ocean today. We're still finding quite big branches in the tree of life that we've never seen before. So that's why it's exciting to be an ocean explorer, for me anyway, as a biologist. Another of my favourites, this is Iridogorgia. This is a deep sea coral with this amazing spiral pattern to its polyps on some rocky bits that we might get around abyssal hills. Okay, and back to the abyssal plain. I had to put this lovely long-legged shrimp in. Look at the amazing length of those shrimp's legs. So it doesn't sink into the mud, it just dances across it as it's looking for its food. And I'll mention one of my favourite inhabitants of the abyssal plain before we leave the last one. These are sea cucumbers again. These are called Parorhiza pallens, and I love them because they're one of the most romantic animals in the deep ocean. Finding food is a challenge down in the dark depths, but also finding a mate is a challenge as well. So there are some pretty desperate measures for dating in the dark. What these animals do is, you know, they're lumbering across, well, crawling across the abyssal plain, eating and pooing at the sea, you know, as we've talked about. And when one Parorhiza meets another one, they stay together for the rest of their lives. They're simultaneous hermaphrodites, so each one is both male and female, and when the time comes, the male bit of one reproduces with the female bit of the other and vice versa. But, you know, if you come across a potential partner in the deep ocean, a lot of species have evolved this strategy. You hang on to them, right? So you might not bump into another one, okay? So they do, when they're not, you know, if they're not ready to reproduce, they will stay together. And you see these lovely tracks that look like railway tracks, these twin tracks. And sometimes you'll see one track and another track, and you'll see them come together and converge, and then a twin track go off. And you know, there's a love story in the deep. So I really do like them. And there you can see a pair here, and they've left that twin track. Okay, near the end of our journey now. Come across that abyssal plain. One last surprise waiting for us as we approach Puerto Rico. It drops away to more than 8,000 meters deep, and we enter an ocean trench. Now, these only cover about 3% of the ocean floor, but they are the deepest parts of the ocean. And people have been to the bottom of the deepest ocean trenches, okay, been to the deepest point in the oceans. And this particular trench, the Puerto Rico trench, this has got the deepest point in the Atlantic in it. And people went there in 1964 in this machine here. This is a bathyscaphe, which is a kind of old-fashioned deep-diving submarine. This is called Archimede. It's French designed, French built. This went to the bottom of the Puerto Rico trench with people in 1964. And there is life down there for us to investigate. So we might see something like this sea pen. That's one form of life we know goes very deep into the trenches. And you get a lot of sediment building up and slipping into the trenches. And then, okay, we'll have our dip into the trench at the end of our journey here tonight. And then we start to, unfortunately, we will find rubbish in those trenches. Okay, that's the other impact. We've talked about fishing, we've talked about mining. Rubbish gets everywhere, and it's at the bottom of the deep trenches. Now, this isn't from the Puerto Rico trench. This is my team. We were working a few years ago. I led an expedition in the Cayman Trough. We were working down to 5,000 meters. We were finding rubbish everywhere we looked. Okay, so it does get everywhere. And that's the big bits we can see, plastic bag, beer can. The microplastics, as you're probably aware, they are everywhere. Okay, ubiquitous. So, yeah, that is a real issue. And we also know that noise pollution, okay, also gets to the deepest trenches. People have put down hydrophones, underwater microphones, at the bottom of the Marianas Trench, nearly 11 kilometres deep, deepest place on Earth. And yes, you can hear human-generated noise. Okay, so that is having an effect. Sound, as many of you probably know, travels much better through water than it does through air. The speed of sound is 4.5 times or so faster through water than it is through air. You can hear things from a lot further away underwater. But that's a problem when we're the ones making lots of noise. And noise affects marine life. Not just the marine life that, the whales and dolphins that use it to communicate and so on, but it affects all marine life potentially in its behaviour, even the tiny larvae that float and drift in the plankton. So that is a worry, and I know you're going to hear more about noise in the future as part of this programme. But okay, let's climb out of our trench, okay, and amazing thing at the end here, this is something called the amphitheatre escarpment. Okay, this is coming up towards the San Juan and Puerto Rico. We're coming up what would be continental slope, where we start, like what we started on as we left Lisbon. But here, great blocks of it have fallen away and sunk and slipped down into the trench because of the geology here. And we'll see amazing animals, I'm sure, if we were coming out of the trench there, climbing up the amphitheatre escarpment. We might also get some amazing surprises like this. This is what we call a cold seep. So we looked at those hot vents on the mid-Atlantic ridge. This is another hot spot of deep sea life where methane is getting forced out of the seabed because of the geology. And there things like this will be dotted along the amphitheatre escarpment. And all that brown stuff, we're having a close-up here, they're mussels. Okay, this is 1,000 metres deep. This is actually not, I couldn't find, there's no exploration, well, there's currently going on exploration near Puerto Rico. This is from Trinidad and Tobago, but it's the same kind of geology. So amazing new species of shrimp. In fact, see that guy there? That is the juvenile of that new fish species that I showed you that my team described. The adults live at hot vents, the juveniles we found living at cold seeps. And they're across 2,000 kilometres or so. Okay, so back up to the surface then, at the end of that crossing of the Atlantic. I think if we could take that kind of a hike, for real, we would appreciate how rich, how varied the deep ocean floor is. Okay, because we tend not to imagine, to think about it. If we do, we might think, oh, it's just a plain of mud. No, it's not. It's just as rich and varied as land. There are mountains, there are volcanic rifts, there are trenches, there's all that exciting stuff. Different marine life where we look. And I've only been talking about what lives on the seabed. I haven't talked about the incredible things as we've had our journey all the way across there now. I haven't talked about the amazing things that live in the water, away from the bottom. That's a whole vast realm we're only just beginning to explore with the technology we have today. And it's great that we're able to do this because right now we face a choice for the future of the ocean. We are researching what's out there, we're discovering new things, and we need to be very careful in the path that we choose ahead. So to give you some idea of that, you have all probably, I suspect, used the deep ocean today without realizing it. If you've been on your smartphone or on a computer or whatever, and you have visited a website that's hosted in another country, or you've used social media, or you've sent an old-fashioned email, you have communicated with a computer on another continent to get that information, exchange information with that. How did that information get exchanged? It did not bounce around off a satellite. It was carried by a network of deep ocean cables, fiber optic cables. Here's the global network. 99% of our modern telecommunications traffic, intercontinental phone calls, this is how it's carried these days. So that's a relatively benign, passive use. Your signals will have crept past those deep sea sponges and you didn't realise, and fortunately they didn't realise. It doesn't really have much impact on the deep ocean apart from exactly where the cable's laid. But there are other impacts that we're having, which we've talked about and seen, okay, that are much more severe. And this gives us a fundamental choice because our everyday lives are affecting the deep ocean and affecting the life in the deep ocean at the same time that we're still exploring it and we're still learning from it. So in addition to just finding new species, it's also what can we learn from these animals that survive in these deep ocean environments that we're just discovering and exploring. So here's a little example of that. This is a species called the scaly-foot snail, which I was involved in describing as a new species with one of my research students. And it's actually from the Indian Ocean. And unlike every snail on land or sea that you're familiar with, this is the only snail in the world that has metal plates covering its fleshy foot. that you can see here. That's how it copes with the environment, the hot springs where it lives, lots of dissolved metals in those hot fluids. But its shell has a very special layered structure. 3 layers, very complicated, different bits in each layer. But what matters is it's very, very good at resisting mechanical damage. Okay, if you kind of try and crack this with a hammer, it won't crack very, very well. The cracks will kind of self-heal from the layer underneath. The whole thing is designed, it works very well to resist mechanical damage. So guess what? Material scientists are using the principles that we can learn from this snail's shell, unlike every other snail, to design better crash helmets, better body armor, better pipeline protection, things that will benefit us in our everyday lives. And that's material science. There's also, of course, biomedical science. So a really strong example from the deep ocean. This has been 20 years in development. I've not been involved in this, but over 20 years, whole teams of people around the world have taken a bacterium from the deep ocean, taken a kind of chlorophyll molecule that it contains, and modified that into a treatment for prostate cancer. And they published their final paper. It's not yet available on NHS in the UK. It's probably 2 years off being made available worldwide, but it's had all its human trials now. It's in the very last stages of regulation. And it's already making the headlines. Prostate cancer drug based on seabed bacteria brings complete remission for half of patients. It's extremely effective for certain types of this form of cancer that are resistant to other treatment types. So there is so much we can learn from that diversity that we're still exploring. To me, I kind of think of it's a bit like a library. Life in the oceans and deep oceans, it's like a library. We can be in there, we can be learning from the ingenuity of nature that life contains. And here's the Library of Alexandria, you might be familiar with from history, which burnt down. And our ocean library, I feel like we're playing with matches in it right now, with everything that we're doing. So the future is very much down to you, as Felix was saying. Okay, we have all the pressures that the oceans are under. It's the previous generations of us who have sleepwalked into that situation. But that doesn't have to be the future that we follow. And it is down to you. It's down to each one of you and the choices you make. And everybody from, yes, scientists, but to explore the oceans and to derive benefits from the oceans, to get people thinking about the oceans. We need everybody. We need scientists, we need engineers, we need lawyers, we need writers, we need filmmakers. It doesn't matter who you are, what your interests are. The future health of the ocean is the future health of us all. And so I encourage you all to be ocean ambassadors. Thank you very much.
Thank you so much. Thank you. I think the point being that you said we're playing with matches in the library, and what's lovely, you brought together these disciplines, and that's the whole thing, science, and we learn from it. We're not just lecturing. Our best partner in the world is the ocean. Thank you so much. There's time for a few questions. I'm sure Jonathan would like to answer anything you'd like to ask you.
Sure. Yeah.
It was really interesting to hear you talk about your discoveries with the ocean. I was wondering, what do you think is the greatest lesson from the ocean we can all take away in our daily lives?
Wow, that's a very profound question. We're connected to it. It doesn't matter who we are, where we're living, how we're living, we are connected to it in lots of different ways, and that's what we're understanding. It's part of our planet's life support system, as well as learning from it and so on. I think there is a future where we can live with the oceans, and where, more to the point, the oceans will help us all to live better. I mean, kind of what's underlying a lot of this is human population growth. When the first people dived into the deep ocean, 1930s, there were 2.5 billion people on the planet. Now there are 7.6. Now that's a success story. That's a success of modern medicine, reducing infant mortality and things we definitely want. But it means we've got unique challenges in your lifetimes, because we think the population will level off at 11 billion by 2100. So we've got 80 years to figure out how 11 billion of us can live sustainably, all you know, with equality of opportunity and benefit. And the oceans are going to be at the heart of that. So that would be, that's the challenge I see.
What got you interested in oceans and ocean exploration?
Largely a series of accidents, I think, like most people's lives. When I was very young, I was late learning to swim. I was scared of the sea, I was scared of the water, and it wasn't until I put on a mask, before I knew how to swim, I actually learned to snorkel. And once I could see underneath, I wasn't so scared, and I wanted to see more. So that kind of got me interested in this world that was down there. Plus I read books about it, some lovely sort of adventure-y type books, and thought, oh, this sounds, I didn't know there was stuff still to discover. But I did want to be a vet for much of my time growing up, because I've always loved animals. But then I realised I was more interested in what animals do than fixing them when they go wrong. So I ended up studying zoology at university, and there wasn't a huge amount of ocean stuff in there. That was everything. It was lions, tigers, insects. There was some ocean stuff, but not a vast amount. And purely by accident, one day I was walking through a university library and I saw a book that had a picture of a weird-looking creature on the front, some sort of red-plumed worm in a white tube. And I thought, okay, I'm a final year student. I should be able to tell you what type of animal that is, and I have no idea. So I took the book down. It was a whole load of research papers, brand new, about life at these deep-sea vents, which don't depend on sunlight as a source of energy and so on. And I'd had none of that in my lectures. And I thought, why have I not been talking about this? This changes the rules of biology. And the fact you can discover something like that, I was just captivated by it, and that was it from then on, really.
So you talked about how some of what you do now is talking to politicians about why they shouldn't be mining in the oceans for all of these things. What have been the reactions of some of these people in power? Have they been for it or against it?
A mix. I once had 45 seconds of a UK science minister's time, not the current science minister, they were having a tour of something, and I thought, right, I can get one message across to them. What I want them to realise is the UK's deep sea territory, because we have all the UK overseas territories like Ascension and South Georgia and so on. The UK's deep sea territory is 27 times bigger than our land area. Right? So I think it's an important part of our country, if you like, and what we have responsibility for. Anyway, I got this across to them, and they looked at me and they half jokingly said, yes, but there aren't any voters down there. Oh. And their aides were sort of going, oh, don't put that on social media. But I mean, even as a joke, it was pretty dismal, I thought, because there are things voters care about. There are economic opportunities, there are environmental responsibilities. So that's the message I try and get home. But I have met with very receptive politicians. I recently had a chance to give a talk to a big group in Parliament and write an article for their parliamentary magazine. And so, I think people are listening. And in fact, there's a select committee, which is part of how government works, has just had a big inquiry about sustainable seas. Deep sea mining was part of it, and we fed information into that. So I think that there are good politicians who are listening.
Building upon Olga's question and your response, I can imagine that it's really, really difficult to get people to engage in something which seems so distant and which is not as charismatic as a lot of conservation at the moment. What other tools, aside from the services that the deep ocean can provide us, do you engage with to allow politicians and the greater public to understand? I think the biggest service the deep ocean gives us is wonder, its ability to inspire wonder. And oddly enough, when I talk to a lot of public groups, to be fair, deep sea mining will probably have less impact directly on human populations than mining on land, which we know when it's mismanaged has terrible impacts on local communities. People are really emotive about the idea of mining the deep sea because to them it embodies an idea of a pristine wilderness. I mean, actually it isn't. We've been affecting the deep ocean for centuries, but they just, even if it doesn't affect human communities directly, it's like a line in the sand. It's a step too far. They don't want to see us take that step, which I think is really interesting. So it's not necessarily about the direct economics or whatever it might be. Getting people involved in ocean exploration where we have that opportunity, where they can actually take part in, share in that journey in the same way that, astronauts beam pictures back from the moon and so on. We can do this in our everyday lives. Thank you.
Could you give us
estimation of how much the oceans have yet to be explored?
It's very hard to put a number on it. So how much of the ocean is still unexplored? It's very hard to put a number on it because first we need to define explored. Does explored mean we've got a map of it? Because doing that clever stuff with satellites, we've got a map of the entire ocean floor, but it's only to a 5 kilometre level of detail, which means seamounts don't appear on it. Most seamounts don't appear on it. So, you know, that, I wouldn't say that was explored. A level of 100 metre level of detail just for mapping, about 10 to 15%, maybe creeping up to 18% because it's going up all the time. That's about where we are now. And that's similar to the maps we've got of the surfaces of Mars and Venus, where there isn't seawater in the way that blocks radar. That's the problem. If we mean seen by human eyes, though, then it is let me think about it, it's about 1/2000th of 1%. Okay, it's tiny. And that's cameras, that's not just people in mini-subs, that's towing cameras and all the rest of it. But then, to me, you know, does that mean explored? Because I take my dog out for a walk in our local woods, and the first time I ever went there in one season, there were various plants flourishing, and then in another season it's completely different. Would I have said, oh, it's explored, when I've just visited it once? So exploration has a beginning in making a map, and at different levels of detail, but it actually doesn't have an end. So, you know, that's kind of a way out of the question, I guess.
As someone who wants to go to university to study science, more specifically biology, how important are these more practical elements compared to theoretical or academic? And how can I ensure I'm quite concerned about going into science? How can I feel my future's going to be full of possibilities that I'm going to have hands-on experience with nature?
Right. Yeah, lots of different ways in. You know, a good foundation first degree. So I didn't study marine biology as a first degree. There are whole degrees in it if you know that's where you want to go. But actually I enjoyed doing general zoology because it was a broader overview and it was a mix of skills. So I think that's something to consider rather than specialising too early. But then just make sure there's a really good practical program. You know, are you going to be out there in the field, you know, collecting stuff, analysing stuff, you know, getting that broad range of skills. And it's not necessarily just lab type stuff. I think to be a modern scientist, it is about, you know, I spend most of my time writing, not actually doing lab work. And I spend an awful lot of my time talking to politicians, to people who might fund us, that kind of thing. So getting that broad range of skills, I think, is really important. So see if there are opportunities in a program, you know, for that wider curriculum.
Yeah, so my question is specifically on Antarctica.
Mm-hmm.
So it's considered one of the largest natural isolated systems as a consequence of the ACC.
Mm-hmm.
But if we're looking at marine litter, have you personally, or do you know of any scientists that have picked up evidence that microplastics in large marine litter penetrated that environment?
Microplastics, yes. So Kath Waller, who's at University of Hull, and one of her colleagues at the British Antarctic Survey, they published a paper fairly recently about microplastics in the Antarctic. And I mean the Antarctic Peninsula. We know that stuff on the subantarctic islands is beyond that barrier. And so microplastics, yes, I'm afraid they're everywhere. The good news is the larger stuff does tend to get kept out of there by the ocean circulation. It does wash ashore on the subantarctic islands, but not much of it reaches Antarctica proper. And the Antarctic Treaty that governs all human activity on the continent at the moment is very effective. It's very strict and it's very effective. So 40,000 tourists every year visit the Antarctic Peninsula, but the rules are so strict and all the waste every year from all the bases is shipped out of the Antarctic. And I've not seen any litter down there, any visible litter. We know the microplastics are there, but the other stuff that I've seen everywhere else in the ocean, I've seen visible litter, not in the high Antarctic. So we can do it.
This talk was really inspiring. Thank you so much for it. But what are some small changes we can make to our daily life to help the ocean? That's my first question. My second question is, this is something I've always wondered. Much like colonization, do you think that your exploration of the ocean is actually causing more harm than good? Or could it be destroying some things? Or you discovering more things would make humans, as we have an insatiable need for so many things, as you explore more things, like find copper, humans start destroying more, we're crazy people.
Excellent. So changes we can make in our everyday lives, there's lots of great advice out there. There are many parts to what I call personal choice here. Part of it is our choices as consumers, because we've seen with plastics and awareness and changes and you know, industry now looking at alternatives and so on, that does drive change. So, you know, there are great websites now that will tell you about reducing your impact on, you know, non-recyclable plastics and so on. You get advice on that, everything from toothbrushes to obviously plastic bags and you know, and coffee cups and that kind of thing. Similarly on the fishing, the Marine Conservation Society publishes this amazing, it's online, you can get it on a smartphone, this amazing guide to what's sustainable fish species and what aren't, and they update it all the time because fisheries do change. Some that were in danger now have been turned around through better management, so that's a really good resource. But interestingly, there was a bit of criticism at the end of Blue Planet 2. I did say a thing about personal choice in a little quote that was used, and got a bit of stick in The Guardian and New Statesman over this, because people equated that with consumer choice. And people said consumers changing isn't going to really turn things around. It's about deeper, more structural change. So actually, personal choice includes who you vote for. You know, it also includes where my pension funds are invested, you know, because that's actually what has propped up the fossil fuel industry for a very long time and that kind of thing. So it's about this greater awareness. But I mean, all of that does exert a change. And, you know, we can only ever be held responsible for our own choices. But it is this idea of choice that is fundamental. So you said, are we at danger of sort of repeating this future through the exploration that we're doing? In terms of environmental impacts, you know, when we go down shining lights and stuff, we do take that into account, and we are careful not to be having an impact from trying to understand something. That's the last thing we want to do, is destroy it by looking at it. But this sort of choice for the future, you know, if we find copper, then people will rush in to mine it and so on. No, that's actually how I engage the policymakers. It's about, you can look back at history, you can look at our track record everywhere from deforestation of Easter Island, which led to the, you know, potentially the decline of the Rapa Nui, you know, the decline of the North American bison to grind up its skulls for fertilizer, you know, and today we've got things like palm oil and so on causing real problems. We've always rushed in, overexploited, and then said, oh, hang on, we're having a terrible effect here, let's do something about it. The point about the deep oceans, particularly things like deep sea mining, is for the first time we're ahead, and we're trying to get a message out ahead, and we're saying, look, if we want fundamentally to have a future of as a species, we have to kind of grow up and stop just doing things because we can, which is a very sort of adolescent thing that we do, and start, you know, not doing things, you know, realizing that just because we can doesn't mean we should. And sooner or later, for us to have a lasting future, we've got to show that we can make that choice as a global society. And with modern communications, I think, you know, we can get these messages out there, we get people involved. There is a great effort. I was at a meeting in London earlier this week, and we had a big discussion about democratizing ocean science, using it as a tool, but people can share in the oceans and share in the decisions for the future of the oceans, and make sure everybody is represented in that process.
Well, I just want to immensely thank Dr. Jonathan Copley for sharing his time with all of us. Thank you for being here, and those who wish to stay for a little longer, you're very welcome. Thank you very much.